Welcome to the Solve Fast Labs podcast. I'm Karthik, and today I have somebody really special. So I've known Naveen. I have another name by which I call him, but let's stick to Naveen for this podcast. So I know Naveen from the college days. So both of us went to BITS Pilani, and then as fate may have it, we then did our masters. I did my masters in Chicago while Naveen was doing his masters as well in Northwestern. After that, it didn't stop. We both were back in Bangalore. We spent a lot of time together. So yeah, we go back a long way, it's safe to say, and we still are in touch outside of our professional world. So yeah, the main thing that I'd like to take your attention towards is what Naveen has done since his graduation days. Now he's the CTO of Ati Motors, and Ati Motors Sherpa platform is running close to 1 million missions and across factories worldwide. So his customers include Hyundai, Samsung, Bosch, Schneider Electric, a bunch of companies I might have missed. They've just raised a 20 million Series B funding, bringing their total funding to 37 million. They're a very highly respected startup. I was speaking to a VC contact of mine, and then they were saying how highly respected Ati Motors is in the startup circle for robotics in Bangalore. So I'm super excited from multiple angles to have Naveen in the show. So welcome to the podcast, Naveen.
Thanks for having me, Karthik. I think it's a pleasure. And as you were talking about, our association goes back to nearly 3 decades as college boys, and then at the same time had kids around the same time. It's been a long journey together. And it's a pleasure to talk about, uh, things related to what I do as my everyday job with you.
Smashing. So BITS Pilani, let's go back to BITS Pilani and our days in Chicago. Okay, so we've known each other. We always know that you were somebody who was very good, although a bit lazy, which is where you got your other Bitsian name from. You were doing your PhD in electrical engineering, focused on wireless communications. So I don't remember you talking about robots back then. When did robotics first get on your radar?
First, robotics got on my radar when we were doing toy projects together with my older son. That's when robots really got my attention. Of course, it's very different from the kind of robots that we do in our company. But that's what really fascinated me. Those little Arduino, Raspberry Pi type of projects, those robots that you would make, which are like starting out with line followers and then something slightly more complicated. Right? The fascination was like, how do you make this in real life? And you can actually put it in people's places and get some value out of it. So that part was like very, very interesting to me. That's when I was seriously contemplating, how do I move away from wireless to doing something in robotics? So I had not really thought about like changing fields till that time.
I see. So this is great because a parenting, if I may rephrase what you're saying, you're basically saying a parenting task or a parenting chore actually led you or gave you some inspiration into starting or pivoting into robotics. Would that be a fair statement to make?
I think that is a fair statement to make. That's precisely how I got my fascination with robotics was, because it was much later in life, right? Like there was my grad school days, and after that, like about a good 10, 12 years, I was with like all these telecom companies, Motorola, and then Motorola was acquired by Nokia. And then I moved to this startup called Altivestar, which again was specializing in like 4G and 5G networks. Right up till then, I was not thinking of AI or robotics or anything like that. So we had our first kid, and he was interested in these kind of projects as he grew up, and that's how my fascination too was.
Great. So let's go back to your 10 years in wireless. So after you graduated, you were in Motorola, you were in Nokia, then in another company called Altivestar as principal engineer. So what were you thinking career-wise when you finished your PhD and then you started in wireless? Did you think that, hey, this is where I'm going to retire?
It was like that. It did feel like that. See, one thing is that at least my worldview back then was very limited. So that tends to happen if you have stayed in college for too long, which I did, about 10 years of undergraduate and graduate studies, right? So your field of focus starts narrowing down. You get deeper, but the number of subjects that you read is also narrower. Like at least back in the day, that was my college experience, and that was my postgraduate experience. So there were these set of problems which are fascinating at that time in wireless networks, and I wanted to solve that. Place like Motorola had those kind of research opportunities that they would give for a fresh PhD, and you can go in and you can explore these kind of problems. And typically, I can tell the kind of what problems researchers would solve for wireless networks, right? Spectral efficiency is the biggest deal there because people spend a lot of money uh, auctioning for spectrum. So how do you get the best bang for the buck, right? Like that means that what is the maximum data rate that you can pump for every hertz of spectrum that the telecom operator owns? And the company that gives the solution that's the highest, that tends to be like a differentiator, right? So
Makes sense.
there are a bunch of these complex algorithms that you will tend to piece together in order to get very high spectral efficiencies. The most important thing is like this, what we call as scheduling algorithms. Like you have a time budget and you need to like cater to the data demands of multiple users. Like before you start with voice, then of course from 3G and 4G it's become more data focused. So so how do you like schedule different users? Some of them will be like premium users, some of them will be like common users, some of them will be closer to the base station with very good signal quality, some of them will be like in indoors and very poor signal quality. So you'll be spending more effort serving one over the other. Like how do you like balance all these things?
I
Another
see.
problem that they tend to explore is that this mobility management. Classic pathological problem is like you have a bus full of people moving from one base station to another. Like how do you manage to onboard them from without losing their calls, right? Like no one should drop their calls. But obviously you're not geared for these kind of peak capacities. So how do you solve these kind of problems? So there is a lot of math involved, and you can formulate this as very interesting optimization problems and so on. From of course, what I'm telling is ancient ways of doing it. Now I hear that everything has become ML. They're solving these things using machine learning, but that's the kind of flavor of problems I was telling him. But the what I was getting jaded with was after 8-10 years, the problems tend to be a little repetitive,
I
and it
see.
didn't feel like you are going very far with it. And I thought it's a good idea to explore a different set of problems. And that's when I started teaching myself ML and robotics and was doing these side projects. And that really made me fascinated about, hey, maybe, there is this entirely new line of ideas that you can explore and you can actually think and work on those. Now, the catch is, how do you get paid for it? How do you pursue these new things and still make a living out of it? That was much, much more difficult for me.
Interesting. That is, it's all you always, as a researcher, your initial, I guess, after you've done your PhD, you still want to continue and contribute in that field and explore new problems. But I can see where you're coming from. After a while, you don't want to be. There's an old Tamil adage which says, something similar to you don't want to grind the same batter. And people who probably understand Tamil will probably understand that. So does Naveen. Naveen. Yeah. So I can see that, you started exploring other bits, which is great. So let's move your timeline to 2017. If I'm not
Yeah.
wrong, I think me and my relative were having a conversation about this Ati Motors conversation startup by
Yeah.
your founder, Saurabh.
Yeah.
And when we were having the conversation, I immediately thought of you because you were
Yeah.
probably the brightest in my known circle, at least from bits. Having done a PhD, having spent a lot of grunt time, as you said, 10
Yeah.
years in academics. So the first thing I thought was you, and I connected you both. Do you remember that first conversation? What was your
No,
reaction when Saurabh
100%.
pitched?
100%. Like I mean, I owe this opportunity to Karthik. He is the one who connected me with Saurabh back in the day. At that time, Saurabh and others were also figuring things out. None of them, it was a good surprise for me that none of them were from a robotics background, but they had been thinking about this problem for a while. And they also had some good ideas on how to commercialize it. So I definitely didn't have that kind of a perspective, but they were far down that track and they were very early. So in that sense, all they wanted was one more person who could like think along with them, work hard, try to figure out what the final product should look like and so on. And they were very welcoming in that sense. It was not a problem for them that I was not from like a robotics background, which was an issue with some of my previous job searches, because at least in India, you tend to get valued very highly the more you specialize in a particular domain. But if you get in as like a newcomer, there is like a bit of ageism that creeps in, even at like resume screening level. I've tried to consciously avoid it in my own recruitment after that, but I faced it, and I'm sure like hundreds of them face it, and it's not so easy to move from one field to another, despite your best intentions. But that didn't happen at all with Saurabh and company. Saurabh, Vinay, and Saad were the original founders of Ati, and all of them were like incredibly open-minded and very sharp thinking, and they had thought about this problem for a while, and they were very clear that they didn't want to do anything that is regulatory, so that anything that involves the government. So that means that public state autonomy was ruled out, and they would only project themselves as like someone who will make industrial robots, and it's B2B and industrial robots. You need safety certifications and so on, but you don't really need regulatory permissions to sell your products, which they were very particular that we should not go down that track. A startup will not have that kind of muscle. If you're a Google or an Nvidia, you might be able to pull it off, but not a startup that's operating.
I see. I see. Did you? So after had that conversation, and it's great to know that the other founders were welcoming, especially of your jump. In some ways, I've seen that somebody who comes from a completely different industry brings a different perspective as well, and also
Sure.
doesn't have the baggage, doesn't have the biases that, or scars from the same industry, right?
Sure.
So it might have been a good blessing for Ati that you've joined with a completely new perspective. So going back to that conversation, Naveen, did you have any concerns at all, or was it all pure excitement when you made the move?
I had nothing but excitement. I have nothing to lose at all. I am getting paid to learn something that I was really fascinated by. We were building this robot, and so it was nothing but excitement. I had no apprehensions whatsoever.
That's great.
This is fun.
That's great. So let's talk about your moving from wireless communications to autonomous robots. What skills from your wireless background transferred over, do you think? And what is it that you had to completely learn from scratch?
Honestly, at some level, classical robotics is all math, right? Like if you take what's called as a hard robotics problem, which is SLAM, it stands for simultaneous localization and mapping. That is, simultaneously, the robot is trying to find out where it is, and it is also trying to map the environment, right? So that is an optimization problem at the end of the day, right? Like it is trying to say that I've seen place A, B, C, D, and I have come back to A. So that means that I must have gone so many meters north, so many meters east, so many meters south, so many meters west, and I've come back to the same spot. So if it gets it right, then that means that the map is kosher. It has reconstructed a good map of the factory, right? It's at some level, this is just formulated as an optimization problem. And if you understand the math behind it, usually uh, the programming that follows and any anomalies that you see in real life, you can explain it much better. So in that sense, the theory was new, but the fundamentals that you gain from working on wireless research does help you in kind of picking up these kind of nuances. And one thing that you are taught, and hopefully that is something that will stay with me for a long time, is that you're not afraid of reading like a research paper which you don't
I
have
see.
background to. You know that if you read it the second or the third or the 10th time, you will get enough out of it.
I see.
So those are things that from my past training, it was useful to teach myself a new subject. And Vinay, who used to work with, who used to be who was one of the founders, he was also very, very mathematically grounded, and his concepts were great. So we would actually have all these sessions with him, and there was a lot of learning that happened just interacting with him as well.
That's nice. That's nice. And I'm guessing the PhD played a major part as well, right? Because in PhD, you're taught to fail and then you have to be resilient to solve your problem. Do you
Yeah,
think
absolutely.
that
Absolutely. PhD does teach you a lot of things. In fact, I learned a lot in my fourth year of my PhD where I had like almost no results. So every problem that I took, it would hit a dead end, and I don't think I published any papers like entire bunch of like 8, 9 months. And that was a very frustrating time. And it teaches you to be mentally strong and try to regroup and keep trying again.
nice? That's a good cue for somebody who's doing a PhD that failure doesn't mean that you've lost the plot. It helps you be resilient. All right, let's move on to the next segment, Naveen. So the technology and the market segment. So what is the core for people who are new to this podcast and the channel? What is a core manufacturing problem you're solving, and was that the same problem that convinced you to join Ati in 2017, or has the problem morphed in some shape that wakes you up every day in the morning?
So the core manufacturing problem was a little amorphous when I joined, and it became more concrete a year or two later, but it's largely remained the same. We have not pivoted too much out of it. The idea is material tends to get moved within factories, and there are couple of different ways people move it. They could use, they can do it manually. Someone can push it, or they can use like some sort of mechanical ways of doing it, like which is tied to a tractor or something, or it could be semi-automatic, like a conveyor. So there are different ways of moving a material. So the idea was, how do you do this completely autonomous? Like a robot can move this completely, right? And why do you move material? Because it has to be processed at different stations within the factory, and there are raw materials. It gets processed in like some 5, 10, 20 different ways, depending on the factory and depending on the product that the factory is making. And finally, it goes to a finished goods, right? Like, so that's the workflow, any factory that you take. So this movement, how can you do it in a touch-free manner? So that was the initial question. Now our thinking has gotten a little bit more nuanced. Now that that problem has been solved in some sense, I should add something. So different material needs to be handled differently. It could be bins, it could be pallets, it could be carts, or it could be a bike chassis or a car chassis. It could be anything. Everything is a material, right? So payload changes, form factor changes. So you might have a few different robots that are doing this material movement, right? So to some extent, we have solved the material movement problem, right? Now, what the next thing to do is like, how do you do material tracking? How do you track this material along the life cycle of this flow, right? Like from raw materials to finished goods. How can you give like a work in progress inventory to the customer? They can get like spatial analytics out of it. What kind of yields they're getting at different stations? Where are your bottlenecks? What is actually taking the longest? So those kind of material tracking is the next thing that we are solving. And there are like, that's a software solution, AI-based solutions that we are like offering customers. The third part, which really, really adds value, and that's what makes people nervous, is like, how can you also handle material, right? Today, a human worker is actually taking this material and putting it somewhere, and he's like fastening, tapping, is doing something to it to process that material at every station. Can that also be automated? Can a robot do it? Uh, the answer, to some extent, is possible. The humans are much more intelligent and they may be able to do much more. But there is like some of these processes, at least, it looks like it may be possible to automate it. So that's the next frontier, and that's what we are trying to solve next.
I see. So essentially, if you're moving a part from one place to another and it has to be screwed on to to another component in production, you're seeing if the robot can also do that.
Correct. It can also do that, is a question. Or it may be this robot, it might be another type of robot, but the idea is like, can robots do it at all?
I see. So walk me through your Sherpa platform. What makes your approach different from other AMR companies?
So some of these things that we took a call back in 2017, and we have not changed very much from that core philosophy, is that we will not retrofit software on existing vehicles, and we will make purpose-built robots ground up. We'll do this from scratch. So it did take a longer R&D cycle. We did take much longer, but we believe this is been very helpful in the long term. And the reason why we said we should do this is that, one, you can control the quality. If you're working with like a third party to say, give me your forklift or like your tractor, and I'm going to like fit autonomy software on top of it, then you're not in control of the quality of that product, and it
I
becomes
see.
very difficult for you to work with. That's one part of it. The other thing is that you simply can get better optimization, better cost control as well if you do it yourself, because a lot of these things they make the assumption that a human is going to drive it, but that's not true. We are going to live and die with the robot, right? Like a simple thing is like you never need a steering wheel. You can throw it out. So, and there are like bunch of these things that you can optimize if you do it yourself. But of course, it's harder to make, to build a vehicle by yourself. And some of these automotive companies have been doing it for decades. So getting that kind of manufacturing maturity to make vehicles at scale, at quality, took some time. It's a hard problem. It's an underrated problem, but it took us some time. But once you get there, what has really helped us is that it becomes rinse and repeat for different form factors. So we know how to make it for, like, we used to be making only 1 tonner or 1 tonner robots. Now we quickly pivoted and started making like 3 ton and 5 tons. And similarly, forklifts, we started out with like a half a ton one, and we have quickly pivoted and we have moved on to 1.5 ton and 2 tons, and so on. So making different types of robots became much easier because the template is well established. So if you know the vehicle, if you know how to make a drive-by-wire vehicle, that's what they call. So drive-by-wire is like you can use a computer or a joystick to make a vehicle drive as well as steer as well as brake, right? So once you've gotten to that stage, that means that a program can also do the same thing with the vehicle.
I see.
That's the idea.
Okay. Okay, so you mentioned no retrofit. When you said no, I was just curious. When you said no retrofit, are you talking about retrofitting hardware components, or I'm sure you would be upgrading the software to your robots continuously, right? So what can you explain
No,
that a
that is
little
fine.
bit more?
Absolutely. So what I mean to say is, like, you have existing vehicles, like forklifts and tractors that are running in factories. People
Mm-hmm.
buy it by hundreds, right? Like you have automotive OEMs, they typically have like a few hundred vehicles running within their campuses to
I
move
see.
material. Now, the idea is, like, can you make them all autonomous? Now, one approach to doing it is talk to the OEM which is supplying these vehicles, and you
Mm-hmm.
can put a box there with like sensors. You can fit sensors there, and you can try to make them autonomous instead of like
I
a
see.
driver driving it. Correct? You
Yeah.
can hack
Mm-hmm.
through the steering wheel. You
Yeah.
can hack through the gas pedal, and you can
Mm-hmm.
make it autonomous. Technically, you can do that, right? And our approach was like, let's not do that. We will study what this vehicle does, and we will do this from scratch, and a program will do this.
I see.
So that is the ground up approach. And the retrofit would have been the former that I described.
I see. I see. Okay. So you've logged, as I've mentioned early on in the podcast, you've logged, or you're on course to logging 1 million kilometers across 60 plus factories. What
So
were the
I'll correct. We are doing million missions every year, and we do about somewhere between 400,000 to 500,000 kilometers every year.
I see. I see. Okay. So, what were the biggest tech challenges that, say, didn't show up in testing? This is a classical problem, right? Till the product goes to the customer, you don't see some issues. What were the biggest challenges early on in your career? Are there anything now that didn't show up in testing but showed up?
So, I mean, so many things don't work in real life that actually works in simulations, or it works in your even limited lab trials, right? One of the things that it became fairly evident early on is that our test conditions were 1/10 the size of the factories of our customers. So a lot of these things just does not show up because you can't go as fast. You cannot get, the robots won't get lost in our factory because our factories are like literally Legoland compared to like the Bosch and the Snyders of the world, right? They have like these massive factories, but our factory is going to be like one tiny weeny compared to that. So it's really hard to test some of these real life conditions, and simulations also don't help you as much because a lot of it is like noise free, and it's very hard to induce lifelike noise, and it's so those are problems that you will just not see it. Okay, that's as far as the software is concerned. As far as the hardware is concerned, there's lots and lots of learning every day. There is lots to learn, very hard problems to solve. But right now where we are at is that the problems that you see with your robots when they are mint condition is very different when they are 3 months old, when they are 6 months old, when they are 12 months old. There
I see.
is this wear and tear that will happen. There will, mechanically speaking, and there will
Hmm.
be this vibrational stress that the sensors and the electronics components are seeing on a day-to-day basis, right? And it is possible that our software is also not earlier on, it's not resilient to older hardware, right? Like as hardware degrades, right? Like a simple example is that you may be driving a car which is brand new. You hit the brake pedal slightly and it's going to stop. But now the car is like 3 4 years old. The brake pad is actually starting to wear out, and you will make that adjustment in your head, saying that, oh, this car is not new anymore, and I need to hit it hard, right? The software's also got to do it, and that is much quicker in robot land because robots are getting used 24 hours as against you will only use your car for like a couple of hours a day, and that kind of wear and tear will happen over months or years. But in robots, it can happen even in weeks, depending on how rough the flooring condition is and how rough the payloads are, and like what kind of operating conditions it is in, right? Like because it's a 24-hour operation, so it's important to like get adjusted to these kind of changes in the robot's physical state. So that is a problem that it's a constant problem that we are still solving, I would say.
I see. Reminds me of another topic called predictive maintenance, right? So where
Absolutely. Important. Predictive maintenance, very important.
I see. It's fascinating because coming from a software world, you build the software once, it always works. There's no question
Absolutely.
of,
Absolutely.
yeah, so it's a very different challenge that you guys are facing. Okay,
If
let's,
if I may
yeah, go on.
add, right? Like
Yeah.
so think of like the software as like the brain. It has like these sensory inputs and hardware outputs. So it is like processing all the sensors, and it says that this is the action that you need to take. You need to go straight, you need to speed up, you need to slow down, you need to turn left, you need to turn right, and so on. Now there is degradation on both sides. The sensors are also seeing dust and whatnot, looser connections, dust and whatnot, and you could have compromised sensor quality,
Mhm.
and the motors and the brakes are also not listening to you as much as they used to listen before. So the software's got to be resilient to actually understand that there is some degree of compromise that's happened both for the input as well as output. So it cannot be in a state of flux. And that's the reason why people say that it can't be completely classical anymore. And there has to be like some element of learning that you need to have even in your software. And neural nets and all have gotten more attention in robotics in the last few years for exactly these kind of reasons.
I see. Fascinating. Looks very challenging problem. So how did, going back to your product line, I mean, how did the product line evolve from tugs to your Sherpa 10K? Was it customer driven or was it planned or a bit of both?
It's everything is customer driven. If you can keep selling the same product, like thousands of it, then why make new products? It's perfectly fine to do that. So everything comes back to the fact that there were some customer queries that we have to turn back, right? Like we say we had to turn down and say that, hey, this is not going to work out because we don't have that product. And then you make a note of it, and then you say that I had to turn down so many of these queries. So that means that there has to be a market for this. And why are we not making it? Is it a hard problem to make? That's the question to ask. And then say, okay, this is something that we need to start working on.
I see. That makes sense. Every business, even in my startup, keep getting new ideas, but if that idea is not backed by a customer requirement, then it's just an idea.
Yeah, absolutely. One thing we should be wary of is that it can't be one customer, because some customers can ask something very exotic and that may not be the market. But enough people ask the same question and you don't have an answer, that means that it's probably a product.
Makes sense. Makes sense. So going back to your prospects, let's take like the bigger ones like Hyundai or Samsung. What's their biggest fear about deploying AMRs?
Safety tends to be their biggest fear. The second fear that you will see is that, is automation going to slow things down, right? And that's a
Yeah.
valid fear. Uh, Safety tends to be, I won't say overrated, but I think largely a lot of AMR companies do a good job of safety, because we put in certified products and we get like third party agencies to look at the AMR and things like that. But efficiency of automation is a real problem, right? Like that means that you're algorithmically you need to be differentiated. If you do have a human being who's pushing things at like say and you're deriving a throughput of say 10 units per hour, and if your AMR comes in and says that I can do only 5, then we can argue that you need to put 2 of those AMRs to replace a human being. So that is an ROI type of question.
Yeah.
Or they could say that if you're close enough, right? Like if you're like close to that 10 and you can say you're able to manage with one AMR, then that AMR cannot break down like ever, right? Or else the line stops and their production stops. So it's either an economics problem or it is like a reliability problem.
I see.
So that tends to be their biggest concern, is automation coming in the way of me doing my business.
I see. And do you have any numbers that show how your platform has been able to boost efficiency? Security, I can see it's more of a regulatory thing and it's more of a checkbox exercise. But when it comes to efficiency, do you have any examples where your platform has helped efficiency by an order of magnitude?
So more than efficiency, right now I mean, at least there are only 2 things that I can tell, and both of them are a little qualitative and not quantitative, and I can tell that both. The first thing is that when we went, I mean, there was like an upgrade that we had planned in like one of the factories in Bangalore. It's a major automotive component supplier, and the feedback that we got from there was and I had to go out and ask like, what do you like about our product? Like, what do you like about using AMRs and not like manual tuggers, right? The first thing that came to me was, your AMRs behave the same way, whether it's morning or 3 o'clock or during the graveyard shift, like 2 or 3 in the morning, or like when when you're fresh and it's like 10 or 11 in the morning, or like 2 or 3 in the morning, it behaves the same way. The reliability is identical. Whereas what I see, if I make this a completely manual process, I see a lot of people making mistakes when they are doing the night shift.
Yeah.
We are human beings and we tend
Yeah.
to make mistakes a lot more during the night shift. In fact, some of our automotive company customers have stopped running night shifts because the number of mistakes that used to happen in quality control was a mess at that time.
I
So
see.
AMRs and automation is one way to make sure that you can run round the clock. And because AMRs don't know night or day, right? Like they will tend to do
Yeah.
the same thing. And so that is something that's a feedback that I'm getting, saying that your performance is probably not, surpassing human level at this point, but it's constant. It doesn't take a day off during Diwali time. It doesn't. It works at the same levels whether it's like night or day. So that kind of a constancy is something that is appreciated, right? So that is one thing I would say. The other thing that I did like, and this is more from the worker standpoint, and they actually loved it, especially in like tire industries. They loved it that with the carbon suit and sulfur in the air, the fact that robots are now pulling these like 1 ton, 1.5 ton trolleys and they don't have to touch it and they can take more breaks is something that they really appreciated. The idea is like, I mean, in general, we have a lot more relaxed working style because the grunt work is done by someone else, and we can actually take a break and go out and like get some fresh air and come back again, because we don't have to be like managing these carts and things like that. So but these are qualitative improvements which I felt really good about what our AMRs are doing. In terms of raw production numbers, this is something that we wanted to do ourselves, these kind of case studies,
Yeah.
because that will hopefully be good for business.
Yeah. Okay, cool. That's really good. I mean, it looks like you're helping the quality of life of workers, which is a great thing that they're able to be in these non-polluting environments. That is
Of course.
amazing that, your AMRs are able to do that. And the interesting point that you mentioned about night shift, the graveyard shifts having a lot more errors. And I think, yeah, that is something that is true and real in every country. Doesn't have to, it's not limited to one country, right? We are
Of
human
course.
beings, like what you said. Okay, so, and the last question in this segment, Naveen. So what does the ROI conversation look like when you go to a customer? What do they expect ROI? Yeah, those discussions. Can you give us examples about that?
I will not get into the specific numbers, but I will tell at a high level our selling philosophy. Our preference is that customer buys these AMRs as what we call as RAS, Robot as a Service. So it's a monthly subscription model. That way they're not saddled with like some huge capex. They don't have to these AMRs, and like if the tech does not work out for them down the road for whatever reasons, they're not like they don't have to carry this baggage. They can cancel this anytime they want. It's not a problem. And if the technology gets obsolete, again, they can cancel it and they can trade in for newer robots if they want, right? Like, so that's what we usually tell our customers. And it's an all-in-one package where they don't have to worry about service or spares. We take care of all of that. What does this help them achieve? You can see unit economics work out for them every month. What is the money that you're spending to move this material using this AMR every month? If that is less than your rental costs, or sorry, that is more than your rental costs, you're doing fine. You should go for automation. But if it's less than your rental costs, then this tech is not for you, right? Like that, it becomes a very easy conversation for the customer. And one thumb rule is that if the customer is using the robots for 3 shifts as against 1 shift, very likely that in whichever geography he is, he's going to get some savings out of using an AMR, because that means that invariably he's employing somewhere between 3 to 6 personnel to do this kind of tasks, and it's likely that you can make them do something else and not material movement.
Makes sense. Makes sense. All right. That's moving on to the next segment, which is talking more about your business and bottlenecks that you're facing. So, as we were talking about your customers before the podcast started, you mentioned about 75 to 80% of the customers are automated in the automotive segment. So how do you find these customers? Do they come to you? What's working from a lead generation standpoint?
So lead generation, a chunk of it happens through trade shows. So that's where a lot of these AMR companies go to talk to customers, liaise with them, get the first conversation going. Of course, there are some customers that come through word of mouth. There are some customers who moved from one competitor to another competitor within them, and they say, oh, I like your product, I can use it in my new company now. And you also get some bit of leads through inside sales, right? Like, so this is the funnel through which you generate leads. Now, as you correctly said, we started out with automotive OEMs and automotive components. And the reason is very easy to see. A lot of them run 3 shifts. They're very savvy with automation. They've been doing automation for a while. They place a lot of emphasis on throughput. So this is a easy set of customers to work with. But as the time has progressed, we have tried to diversify our verticals. We are now moving into like pharmaceuticals, FMCG, white goods, electronics companies. So we have also tried to move away and say, let's not put all our eggs in one basket. So that's like from a diversification perspective. So the leads that we are seeking are also across verticals now.
I see.
But the funnel is this. The funnel
I
is that.
Makes sense. So what's harder? What's been harder than expected as you're trying to move across verticals, as you mentioned? What's been the problem?
See, as always, like you have to start over every vertical. If you go talk to like a Unilever, they want to understand where else have you done in FMCG. No one wants to be the first person in the pool, right? Like they want to say, oh,
Yeah,
who else has done it? Like
makes sense.
if you go talk to like I don't know, like a Hindware or a Parryware or a Jaguar, right? Like, so they all have huge material movements. Or where else have you done it? Like, have you handled ceramic before? So that'll be the question. If you talk to a Diageo, like, oh, have you guys handled, oh, this looks interesting, I want to try it, but have you done alcohol before? Have you done Heineken before? Have you done like
Yeah,
Miller before? So that will be the kind of questions that you will ask, that you'll get asked. And that tends to be, I would say, I won't say high friction, but there is some friction. And
I
the
see.
minute you tell that this is worked out and like a tire industry, like you're also tires, like would you like to try it? It's a much simpler conversation. And in some sense, that's reasonable question to ask as well, because every industry has its own unique workflows, right? Like now we understand tires very well. Like how do you go from like curing to green tires? We understand it very well. And you know what are the different trolleys, what are the different materials, what kind of takt time you need. But it took like a couple of years for like all our solution specialists to understand that kind of an industry. Now, there are these nuances if you go to like a beer manufacturer, right? And you need to understand that very well so that you can suggest the right automation solution to them. But it takes, I would say, to answer your question in a single line, it takes an enterprising and a little bit of a risk-taking customer to make that
Correct.
jump in the first vertical. Yeah.
You need a friendly customer, as we call
Yeah,
it, right?
absolutely. Absolutely. A friendly customer.
Yeah, and a champion for your product
And
inside.
100, that is true whether you have a known vertical or not.
Yeah,
A champion inside the customer organization goes a long way whether the project is successful or not, because each project has like multiple stakeholders: operations, safety, IT, because you need to get like cybersecurity clearance, you need to get like operational safety clearance, procurement, so maintenance, because after the robots are finished the maintenance team will have to take over. So there are some 6 or 7 different stakeholders, and these are complex large organizations. So the champion inside your org tends to be someone from the ops usually, and him or her have to take that special sense of ownership, saying that I'm going to get this done and I will work with the internal stakeholders and make sure that everything gets coordinated. So it's priceless to have the right champion
champion. Yeah,
inside.
makes sense. So going back to your sales cycle, just for our audience, so how long does it take from like the first conversation in a trade show to a deployed robot? I know it's not a fixed answer, but generally, what is it that your sales cycle? How long? Who needs to
Right now,
sign off?
absolutely. Right now, it's somewhere between 4 to 6 months. It can be as long as that. It can be faster. It can be slower, but the average is somewhere there. And there are multiple things that need to happen. I'll quickly tell what the. So if someone says that, I'll walk through the steps very quickly. So if someone says in a trade show saying that, oh, I love your product and I want to see how it works. So we will give a demo for a day or two, and then they'll say, oh, this looks good, or they'll say, oh, this is not going to work for us. If it looks good, then they'll say, can we do like a 2 or 3 months, a month-long POC, and we'll pay for it. And then you do a month-long POC and then say, okay, this looks good. We'll go to the next step. So we will sign in a long-term contract or we'll buy it outright. And then you have to present a techno-commercial proposal and they'll say that looks okay. And you have to work with their safety team, IT team, get their clearances. Then the procurement team will say, all right, the budget is approved, go ahead and buy it, and then the PO is placed. And then internally you make a robot order and then you deliver and all is well. So this one can take somewhere between 4 to 6 months.
Especially big companies. I've seen in my own experience that companies who are paranoid to sign a service agreement
Absolutely.
can take up to 6 months just to look at the clauses and agree. So yeah,
100%. So that's the reason we really, really like OPEX. We say that it's rental. You have nothing to worry about. You can cancel it anytime you want. We are not locking you in for long term yet. But get going. Start using the product. See if it works for you.
Yeah. All right.
That's why it is.
All right. So moving on to technical documentation, proposals, RFPs. Is that something that's standardized for you? How much time goes into it?
A lot of time goes into it. We have a dedicated solutions team which is just handling these things. We have a standard, whatever document that we put out, that is standardized. But the kind of questions, the questionnaires that come from the RFQs that come from customers, they unfortunately are highly non-standard. So it is time taking to go through these things and then come up with like a solution. I think this is where some of the modern tools are will be very helpful. Like LLMs can help you a lot. Some of these things, but it's unfortunately time consuming.
Okay. All right. Now, an interesting question. So I've got to ask you this one, Naveen. So you were at Ati from 2017 to 2021. Then you left to ArtSpark for about a year. Then in June 2022, you came back as CTO.
Sure.
I've always been curious personally, when I looked at this and when you rejoined, what is it? Why did you leave and what brought you back?
So COVID was a little messy time and I was really burnt out doing these like 14-hour days, and I wanted to go back to academia and like start to teach. And I was teaching at like the Center for Robotics at the Indian Institute of Science. And I was also working at like an incubator art park. And I was trying to find out a full-time job, like if that's possible. And academics have also been very harsh. If you're a fresh PhD, all is well, you can get a job. But if you've not been publishing for a while, it becomes very difficult to find a job. And that happened to me as well. And I was wondering whether I should continue doing this. Like one option is to continue working in this academic setting and rack up some publications and then try again a few years later. That was one option. Or the other option is to go back to startup world, which I understand well. And COVID winded down, and I was also in a better space. I could give more time to a startup job. So all these factors came together for me, saying that okay, struck I didn't strike gold with academics. I have more time, and let me actually go back to the startup world. Then the question was it Ati or was it somewhere else? I chose some degree of familiarity there. It was a product that I understand, and it was a platform that was well set. I thought there was like potential, take it to the next level. So I tend to call it like Goldilocks problem. It's not so small that I have to be there 7 days a week, and it is not so large that whether I come in or not does not matter. It's somewhere in between. My presence and my contributions will have an impact, but it's not. I mean, I can take a couple of sick days off and nothing will happen. I think the company will not collapse. So that way, Ati is like a Goldilocks company for me.
I like your phrase there, Goldilocks company. I will use it when I get a chance. All right. This is my most interesting question that I generally get different answers, and it's called the magic wand question. So you're the CTO, you're scaling to 1 million missions, as you said, annually. What is the one operational bottleneck that's eating your time and you wish you could automate tomorrow? Let's say you've got a magic wand for that. Enough, infinite money, infinite resources question. What is that one bottleneck?
Is it only one? I have so many.
Okay, go on in order of priority then.
So one thing that one thing where I would love to see is that automate everything that our team is doing, engaged in repetitive work, right? Like some of this, especially log triaging, is something that I can see some of our guys, very, very smart engineers, I find them like neck deep in it because the logs tend to be multimodal. It comes from different sensors, it comes from different subsystems. And you need to like put them all together and you need to pour over it to see what the problem is. And given the advances that you have seen in like GenAI, I would bet we spend enough time on it, like at least we can do a decent triage of it, which is automated, and that will save a lot of support bandwidth for our engineers. So that is something that I can see us lose some time. The other thing that I see is that some of our older robots don't have the best hardware. And that has actually sucked some of our time trying to support it because we do have like a 5 to 6 year product warranty. So, I mean, the first generation robots do have some hardware trouble, which we made like 3 years back, but we still need to support them. And that tends to have like a support thing. If I have a lot of resources, then I'll just replace them with like brand new robots. But we don't have that, so we continue to support it and we continue to lose some time on it. So, but the newer robots is more to do with like the robots that we are going to put out in 2026. It's more to do with like I would say I don't think we have too many constraints. Probably we can expand the team a little bit more because some of our team members work very, very hard and I would like to give them a break. But otherwise, we are on track with what we wanted to do.
Okay. So how much time does going back to your couple of problems that you mentioned there, Naveen? One was the triaging of the logs. The other one was the hardware, I guess, the first generation robots. I guess you can't do that. Problem is always going to exist in some shape or form because your robots, like what you mentioned earlier, are going to get old and are going to have wear and tear and are going to need support. So let's focus on the other problem that you mentioned a little bit more. So how much time does your team spend on that? And does it take a lot of your time as well?
Not anymore. I used to do that a lot earlier on, but now it's largely with the team that does it. But this can take like a sizable amount of time on a day-on-day basis. So
I see.
more important to note is that it's not about the time that I'm interested in. It's about the responsiveness of what the customers report and how quickly we're able to put the robot back in production. So that is what I would care about more. And naturally, that has a correlation with the amount of support time that people have to put in, right? But the ideal world, you want the robots to self-heal. They just automatically understand that this is where they are in time and space. They self-heal, and anything that has an hardware problem, then we will have to fix it. And if you have too many hardware problems, then we have the resources to change the robot. So that's the way you have to handle it, right?
Yeah, makes sense. So interesting that you mentioned the self-heal, then followed by products, I guess, or spare parts change, and then followed by a full robot change. Yeah, makes sense. Okay, so let's move on in terms of your time. What does your day-to-day look like in terms of a CTO of Ati? What does your day-to-day look like?
So there is some bit of time that I spend on recruitment. Till I would say like 10% of my time is on recruitment, like trying to talk to newer engineers and uh, their approach to problem solving. I still give out assessments. I still interview. I still talk to people. A lot of it is also offline, non-technical assessments where we go try to make it like in a casual dinner type of setting and understand if these kind of senior engineers are good cultural fit for us. So that is something that I spend about 10% of my time. About 20-30% of my time is involved in reviewing customer issues, because that tells me, and also customer visits, right? Like going to different factories, understanding how does these products get used, what is the customer feedback for it, what should we do better, how do we make the product better. So that is something that we do. And another 10-20% of my time is talking to suppliers and vendors and partners. So it could be like talking to a professor at one of those IITs, the research projects that we do together. It could be a supplier out of Germany or India for like a new battery or an encoder or a safety sensor. So we are always hunting for newer, better, cheaper products, right? So you're looking to always talk to different partners. And then about, I would like to do more of it, because as an engineer, I want to do more research, but that tends to be only 20% of my time, talking to the team on different activities that they are doing. If there is any kind of bottlenecks that they are facing in terms of technical challenges or logistics challenges, see how I can help them unblock them. Monthly planning, weekly planning, quarterly planning. So those kind of work for the team. So that is roughly my distribution.
Nice. So quite a varied kind of role. So varied kind of. So you have to context switch quite a lot, I'm guessing. Once talking to a third party, then problem solving, trying to understand what your customers are saying, and then your engineering challenges. Sounds fun, Naveen. Moving on to your business, slightly different question here. You're expanding in the US. What's harder about selling there versus, let's say, a market in India?
So India is a cost-sensitive market. US is not, but they are particular about certain things. For instance, Indian customers will be forgiving about, I would say, 20% non-automation. You can tell them that, this last bit, you have to get someone to do it, and they'll be okay with it. US customers will be saying that this product does not work for us because it has to be end-to-end, zero touch. I don't have anyone to give you. So culturally, they're okay to pay more, but they're very demanding about a solution. And if they want to automate it in a certain way, they will take nothing less. They will not change status quo that quickly unless they're very, very convinced that this is going to work for them. So that, I would say, is like at a high level, the difference that I have seen between the two markets. But it is also true that Indian markets, you also see some of these customers who will take a chance. You say, okay, this is an unproven product, but I've done a lot of unproven things, and they'll take a chance.
Yeah.
The US customers want a very polished product. It can't be rough around the edges. That's not something that they would accept. And we understand that. So we tend to see that our software releases are at least 3 or 4 cycles slower in the US. The Indian customers get our latest and greatest upgrades, but US customers will probably be like 3 months old.
I see.
They want to get that kind of a maturity. They don't want anything cutting edge, which less it should break something.
Interesting shift between your markets in India and US. Are there any other markets that change the dynamic as well? Do you guys sell into other
Yeah, so no, Europe, no. We are selling in North America now, Canada and Mexico as well. We just entered the Southeast Asia market, Thailand and Singapore. We sold a couple of robots. 2 of them are in Thailand and 2 of them are in Singapore. And we've just started working with some partners in Dubai. So this is the way we have expanded right now.
Okay. All right. So going more on to our next segment, which is the scaling and technology segment.
Yeah.
A couple of things I wanted to ask you first. What does your engineering team spend the most time doing? Is it new features, maintenance, or customizations?
I want to say new features, but I think it's more maintenance and customization. It tends to be that way. A lot of these robot projects, people have realized this already. The robots are just one piece of the puzzle. It does not work without some sort of software customizations. So how in our world, it's about material movement. So the robot has to pick material and it has to drop material. So where it's picking the material and where it's dropping the material tends to be very unique for every customer. So there tends to be some sort of ask. Can you work with this particular trolley? Can you work with this particular hitch? Can you mate with this conveyor? Can you give me this API access to do something? Can you work with my traffic light API or a lift? I have a lift. Can you go up in a lift? So all kinds of these kind of custom asks that will come from your client, and the software team tends to work on them, and that does take a bit of time.
I see.
So one way to handle it is like if you're a big enough company, then you can get what we call as an application engineering team, which is just focused on these kind of activities.
Okay. All right. Moving on to your Athiverse platform. What's the vision for you beyond the material movement? I think you covered a little bit early on in our conversation. What would you say is the vision?
So this Athiverse, the vision behind Athiverse is that we should offer a total automation solution and not just be restricted to point-to-point material movement. So what that means is that how can Ati get deeply entrenched in the customer's digital and physical infrastructure within their factory and add this sprinkle of spatial analytics that we are able to give. We understand what material we are carrying, where is it going through, and how often is it required, and how fast is it happening between these different points. Now, there are so many touch points in between. Like it could be a conveyor system, it could be a smart traffic light, it could be a hooter to give emergency alerts, it could be a lift, and there are many other such products that are there within a factory, which are physical. And there are digital products, where you have an ERP system, a WMS system, an SAP system, which is telling what is the material requirement at each station, what is the production plan for that day, how many of these workflows need to be orchestrated, and which trolley needs to go where, right? Like all these different kinds of questions. Now, can the Ati solution be the focal point for doing all this orchestration? So that is the vision behind Athiverse. And for that, you need to have a basket of solutions, right? Like you might need like a smart infrastructure camera to track things, for instance. So these kind of products, we started making it as an outcome of all our customer conversations. But we also understand that this is such a vast space. It is helpful to have strategic partnerships with other industrial AI partners as well. So it's not like all of it has to come from Ati. It's just that we tie up with the right partners, and with the magic of APIs and interoperability, we should be able to pull together a very interesting solution for the customer. But there are customers who have said, we love your solution, but you need to make your own wireless network, a private wireless network. So starting as a robotics company, we had no idea how to do that, right? And we don't want to do it. But you realize that if you don't do it, this solution will not work for that particular client. So you have to rope in the right partners, and you need to actually make these kind of things happen.
Interesting. So moving on to the GenAI moment in time. So November 2020, ChatGPT dropped. A lot of things change in the world. So what is it that you see has changed as a result of GenAI and ChatGPT and all of those coming into the picture? What's possible in robotics? Are you using it internally at Athi?
The honest answer is not as much. We use it for, I'll qualify it. It is not used in the product. It's used more for tooling. So what that means is that we don't have robots that run on LLMs. That doesn't happen. But to make that software, all of us use Cursor, Claude, utilities to code, and it's much faster, and it does help you catch a lot of bugs, fix things quickly. But if you want to write new features, there's still some distress, and we go back to old ways of doing things. But we have adopted these things to write code. The other place where I found it to be incredibly useful is to do market research, to do product research, to do vendor research. At all these kind of places, it's been very helpful. Internally, it has been very helpful to do analysis on things like tickets, things like our spends, things like any trend analysis that we want to do. All those things it seems to be doing much better and faster than us. So in terms of productivity, it's been helpful. In terms of tooling, it's been helpful. We have not been able to enough with it for as far as the robots functioning goes, and especially with mission critical stuff, we have not been able to do much with it. That said, we have been exploring foundational models to see how we can do end-to-end. These are all transformer architecture, obviously. How can you do end-to-end learning, and how do you do how can you write really simple software or to make robots work in the same industrial environments, but using a foundational model. So that's something that we are exploring on the side. There are some interesting results, but it will not work. It'll work 75% of the time or something, but that is not good enough yet. So it's something that you keep toying with. Some places where we have found it to be interesting is very specific transformer models have been helpful to solve specific problems in perception. So that is something that you do see. But if you ask me the question, has it been life-changing? No. Has it been helpful? Yes.
Okay. So what does it take for, in your eyes, to go from helpful to life-changing? Is it helping in mission critical tasks and actually functionality of your robots themselves? Is that what that jump make it life-changing?
See, it need not be even something that does end-to-end, right? Anything that makes us do two things to me is life-changing. One is if there are these we say there are 4 S's for robotics, right? Safety, speed, space, and sturdiness, right? And if LLMs help us along any of these directions, that would be awesome. Safety is something that LLMs can help in an indirect way, where if you throw all the logs at it and you have an audit that an LLM does and say that indeed the robot acted in a safe, responsible manner, and that is helpful in an audit check, that is also helpful. If an L if a teach and repeat type of module is available to tell the robot how to park in a very, very tight space, or to go very fast in a novel environment. So those are helpful problems. It doesn't have to be a mission critical end-to-end complex problem that the LLM's got to solve. So there are intermediate problems that we are attempting, and I'm sure other companies are also attempting. So if it can solve it, I think that's useful too. I don't know when it will happen. So I still think it's interesting to watch. We will spend some effort and time in pursuing along these threads. But at this point, it's just interesting. It's not something that I would bank on solving.
I see. Makes sense. All right. The last question on your on this segment is, you're doing 1 million missions annually. What are the challenges operationally to get to 10 million? What breaks first for you when your scaling goes from 1 million to 10 million or 100 million missions?
So there are kinds of challenges. One is, first of all, you should sell so many robots. So there is a sales challenge. So you need to grow and so on. The second type of challenge is like you need to, there's a delivery challenge and you need to deliver all of them and you need to commission them, right? Like on site. So, and assuming that we have magically done all those things, right? Like you have sold and you've delivered and you're commissioned. Then comes like operational challenges. I'm sure our cloud infrastructure is not architected when you go 100x, and you will need to like redesign the whole thing. And the way the data is getting piped back in, right? The data pipeline could be suboptimal. It could work for hundreds of robots, but may not be working for thousands of robots, and that would need to be like so that would be the biggest challenge. Otherwise, I don't see it to be a hard problem. The formula is clear as to what needs to be done.
Oh, that's encouraging. So it's a case of, I guess the most important thing is selling more.
Selling
And then
more is the
getting
most
more.
important thing. Yeah. Selling more and installing more is the harder problem. I think operationally it's an easy problem.
Perfect. So we're coming to the end of the podcast. So before we close, let's take our timeline future. In the future, we're going to 2028. What does success look like for you first, and then for Ati more broadly?
I think we've gotten to the stage where Ati's success is intertwined with my personal success.
Yeah.
I will not decouple the two. I would love to see one factory where I would even call it like a dark factory, where everything that happens in that factory is completely done by products that come from Ati. The material is moved, tracked, handled by something that Ati was able to give. And this factory operates with minimal human intervention. That would be a very, very interesting problem technologically speaking, and that would be like a moment of pride for me.
Nice. So yeah, that brings me, I mean, to the next question, which is a slightly founderish question. As a founder
Sure.
myself and somebody who's helped you are a founder in many capacities. So
Sure.
what would be a one advice for somebody who's starting something in this space, for in the physical AI space, as it's now fancily called?
Yeah.
What would be your one advice? I have to say this, in one of my previous podcasts that I did, the advice was very blunt. The founder said, don't do this, right? So is it as drastic, or would you encourage, what would be with that quote, what would your reaction be if some founder comes and asks you, hey, what should I do?
I don't know why anyone will say that. Like, manufacturing is a $5 trillion industry worldwide, right? Like, it's a huge industry. And automation potential is immense, right? And there is plenty of pie to go for everyone. The question to ask the founder is, what is the problem that he or she wants to solve in this space? And the second question to ask is, why is it not being solved yet? Or who's solving it and not solving it as well, and why does he think that he's going to solve it better? So if you have the fundamentals intact and you are able to do this at cost, at quality, I think it's always an enticing opportunity. I am not very comfortable with it, but maybe the founder who has this problem is clever enough to even take this to public spaces, right? Like whatever problems that they are solving, maybe you can put it out in airports and shopping malls and those kind of places as well, which is semi-consumerish, and you have an even bigger TAM, and hopefully it's like even solved. So I don't think they should not solve it because it's hard. I think more people should be solving hard problems. Why should they solve easy problems? I think they should solve it because they've found something that adds value to their potential customers, and they have found an interesting, clever way to solve it. So absolutely, they should go ahead and give it all.
Let's take the manufacturer side now. So if a manufacturer is listening to this podcast, considering AMRs for their solution, what would your advice be? How do they know if they're ready?
The same thing, like there are two reasons to automate their material movement. Is that one, they just don't want, there's probably a need to get away from human involvement as much, right? Like if you're running like a clean room, sterile type of environment, you might not want too many people around and you want to minimize human movement. The other thing is that automation is more predictable, automation is less seasonal, and there is a way they can control it better. right? These are the two reasons that you predominantly see why you want to do material movement. If that is in line with their thinking, the next question is like, can they afford it? I would argue almost all of them can afford it in this rental model. It's not something that's difficult. So the only way to find out if that's going to work out for you or not, you should try out. You can ask whoever your vendor is. You can ask for like, hey, can I take it for a 2 or 3 month trial period? And I want to see if it really works out for me. And if it works out for them, great. So you will know the economics behind it. You will know if there is adoption within their factories. You can know if there is a benefit in terms of the two things that I talked about, right? A 2-3 month trial is like great for them to try it out.
Makes
Okay,
sense.
there's nothing else.
All right, Naveen, we're coming to the end. So it's been fantastic to have you on the show. So from the introduction to Ati Motors, you, Saurabh, and the team have come a long way. I can see from what you've said, it's been an incredible journey that you guys have had, and wishing you a lot of success as you go through this journey. So yeah,
Thank
I
you. It's
mean,
not over yet. We have a long way to go.
yeah, thanks for being on the podcast, Naveen, and yeah, look forward to seeing what our subscribers have to say here. All right, thank
Thank
you.
you for having me, Karthik. It was lovely chatting with you. Bye.
Cheers.